So this is the first screen that a user sees when they open the interface. A couple of things that I want to say about what we, based on the stakeholder-driven feedback. A couple of things I want to say about how we designed the objectives we had in mind when we designed the software. One thing we wanted this to be was very lightweight. There's a lot of malaria modeling, simulation modeling that's done in many universities around the world, but those simulations are very informative scientifically and useful. There seemed to be a need, however, for a tool, a decision analysis tool that was lightweight and could be used by people who weren't modeling experts. That was the primary objective of MDAST, was to get a decision analysis model in the hands of people who didn't know necessarily know all of the detailed simulation modeling on malaria. So what we've done is taken a lot of the scientific literature and evidence and incorporated it into this piece of software. That's the objective. And so everything is supposed to be user-friendly. We've done our best to achieve that. We're always open to continuing to work with potential users about how we can improve this. So, although we do have a version 1 now, so that before we moved, a couple of years ago, we moved from a prototype to actually having a tool that we think is actually usable. And in this case, it's been adapted for a specific region of our Mara district. So you'll see, so just a couple of notes about the organization. On the left, you'll see a green box that says control portfolios. That's all of these boxes contain additional inputs that the user needs to go click through, and I'll show you many examples of this. But the control portfolios is where you decide, for example, what types of interventions you want to look at, long-lasting nets or IRS or RDTs, for example. And then the parameters box underneath that is where the users specify the context that they're looking in. Is it an endemic malaria transmission region? What are the population demographics like? What are the costs of the different interventions that are prevailing in that particular region? And then on the right is where the results, the output from the tool can be found. So the basic structure is you start from the left, you fill in the information you need to in the boxes on the left, and then once you've completed that, you can run the tool by asking for querying the piece of the software for results. In the middle, on the top, you see time horizon, and this is the length of time that you want to analyze the projection. You're projecting these different alternatives over a period of time. And so in this case, throughout the presentation, I'll be focusing on a 10-year horizon, but we allow the user to specify that time horizon based on the particular setting that they're in. There may be a budget cycle that is most relevant, and in which case you can change that time horizon. And then all of the modeling details, one advantage of this decision analysis software is that all of the modeling details, there's quite a bit of layers of modeling here, but it's all visual, and you can click through the entire tool to see specific components or modules. For example, vector ecology, there's a whole particular model in vector ecology, and it's all visual, so you can at least get a sense of how the model is working for the areas that you're interested in. So when you click on this mathematical modeling box, it opens up this box, and I just wanted to touch briefly on the way that MDAST does its computations. So what it's doing after you've filled out all the information and then asked for output, what it will do is it will initialize the tool, and that means it'll run a simulation for about 50 years without any interventions, just to see what the sort of stable malaria transmission environment is like based on the parameters that you've given it. Then it will run a historical simulation of the status quo intervention. So in the case of Omero, we would look at long-lasting nets and ACTs and maybe a couple of other interventions. But it will run that before the present day, and the user can specify how long those interventions have been in place, but it will run those before today. And then it will project forward into the future, and it will project the baseline, which is just continuing the status quo interventions. And then it will also simulate 3 alternative portfolios that the user specifies. So that's the structure, and then it brings all of that material back together and compares the results. And you can interrupt me at any time for questions if you want some clarification. So each one of those simulations contains a number of components that I want to just touch on briefly. So first of all, there is a malaria transmission model, and I'm guessing that some folks in memory are familiar with these types of models. So we use a published model and make that the backbone of the malaria transmission component. This model is by Griffin and co-authors, published in PLOS Medicine. There's a number of other possible transmission models we could use. We've gone over this in previous stakeholder workshops about the choice of transmission model. The reason this one is advantageous is that mainly because the recipe for how to replicate this model is very clearly spelled out in the paper that's published. And it's also an open access paper, so anybody can get it without the need for paying any journal subscription fees or anything. So it's very transparent, and that's why I like it. But you know, if we continue MDAST in the future, it would be an interesting exercise to swap in different malaria transmission models and see if the results change at all. That's a project for the future, perhaps. We also added an insecticide resistance model because this is a relevant concern in Africa based on our WHO stakeholders we've spoken with. And that's also based on a published paper. And then finally, we added, there were some areas where there simply is not published data, and so we had to do some of our own modeling. This was as limited as we could make it be, but for example, long-lasting nets. People thought Tanzania's got a long history, or it's worked quite a bit with long-lasting net distribution in various forms. And we wanted to try, this was actually a request from a previous workshop in Tanzania that was to provide a more realistic representation of long-lasting net distribution. And so we've created a model for that, both on the retail side and on the mass distribution side. So that's something actually we hope to fit to more data in the future. So I actually would like to speak with you individually. And some of you who have data on the Tanzanian programs, I would love to speak with you individually on how we can refine that particular component, this long-lasting net component. And then as we'll see today, we also incorporated a component that's critical for what I'll be talking about on diagnostic testing, and in particular how RDTs can be expected to work with other malaria control interventions. So that aspect is critical, and we had to develop our own model for that, but it's fairly straightforward given the transmission model. So that's just a minor, moderate incorporation. So this is just an example. This is an example of the malaria transmission model, and also an example of the use of influence diagrams. So in this case, this methodology is actually a systems dynamics model of malaria transmission. And I won't get into too many details, but I will. This is almost replicated from the paper that we use for this. But I will say that, for example, there is a lot of the authors of this paper give a lot of serious attention to immunity. And so immunity is one feature that's captured in the tool.